Okay, so this week I just wanted to quickly talk to you guys about logistic models and how you might be able to apply them to your project and what the results might look like, as well as talk about what I'm expecting for the final project presentation recording. So logistic regression is a technique that can be used to examine the relationship between a dependent variable, usually a binary variable, but can be ordinal regression, etc. But for today's case, we're going to assume that it's a binary variable, and then you can use as your independent or predictor variables can be either other binary dummy variables or continuous variables. And in our case, with the overcrowding research, we may be able to use as our dependent variable, you could develop a variable that is whether overcrowding exists in a particular time period. So using the NEDOX, if the NEDOX is greater than 100, it would be considered overcrowding. If it's less than 100, then that's not an overcrowding state. So when it's greater than 100, that would be a 1. And if it's less than 100, then that would be a 0. Alternatively, we can look at other aspects of overcrowding. With certain levels of overcrowding exist in a time period. So maybe you're only interested in when the hospital is in a disaster level overcrowding situation. So only when it's greater than 180. So you could make any NEDOX value greater than 180, 1, and then everything below that 0. And then your model would be trying to predict when the hospital is going to be in disaster level overcrowding. So the form of our logistic model is the log odds. So we're trying to predict basically the probability of it falling into one of those two buckets. So with overcrowding, is it the probability of it overcrowding would be a 1, and then not would be a 0. The beta 0 here is the intercept, and then each of the beta 1 through beta n would be the coefficients that are produced when we run our regression model. The other thing we need to look into is to develop a threshold value for when we predict a 1 and when we predict a 0. So this is what the logistic function looks like. It has a sigmoid shape to it, and all values are going to be between 0 and 1, which is why we're looking at this binary. The way this curve works is as it approaches 1, it gets infinitely closer and closer, and on the other tail of it, as it approaches 0, it gets infinitely closer and closer, but it doesn't touch it. And then if you look right in the middle of the screen, if you think of that as our threshold value that we mentioned on the last slide, we want to move that threshold value so that we can improve the quality of our model and its ability to accurately predict our outcome. So we're going to talk a little bit about accuracy and sensitivity, specificity, and how we can calculate those out and what they mean relative to this sigmoid curve. In RStudio, we can use the GLM function, which is what I've suggested you use so far. And after we decide what model we're trying to model, in this case overcrowding, we run our model, but then we want to take a look at our coefficients. First, are your coefficients statistically significant? And second, what is the magnitude of those coefficients? The higher the magnitude, the more it's going to affect the... Yeah. How you doing? You have a question? Bruce? So I'll keep going about on our coefficients. So let me go back and share entire screen then. But I want to get to. So with the overcrowding model, I set up a regression.
I'm not getting any audio.
Can you guys hear me? Okay. Larry, can you hear me? Okay, let me go back to.
Yeah, I can hear you. Sorry, it took a second.
Okay, good. So we have our logistic model based on our binary. I think in this case, I was looking at the NEDOC score 6 hours before it went to disaster level overcrowding. And then I have the 5 variables that actually change in our time period. The threshold was set here, and you can adjust that based on the sigmoid curve I was talking about earlier. When we run it, we want to look first at our coefficients here. And we can see that the only ones that are really statistically significant are the number of critical care patients and the last admit time. And the number of critical care patients in this model has a higher magnitude, so it has more of an effect on the likelihood of this disaster level overcrowding occurring in 6 hours. So now that we kind of understand a little bit about the problem in your particular project, what I'm expecting is, now that you've determined which variables are really affecting the overcrowding, what are your suggestions on how can we make that better? I know one student had pointed out that we could increase the number of physicians in the ED to try to take care of these critical care patients or something like that. But so now,
so just to clarify, the model that you just showed us, you said 6 hours before it hit critical.
Yeah, this particular model that I was working on is looking at predicting emergency department overcrowding 6 hours before it reaches disaster level. That was just my particular model.
May I ask why you went 6 hours before?
Because the chief medical information officer asked, he said, if I could know 4 to 6 hours before it happens, I could bring in staff and support and increase discharges. So that's just the time frame he was particularly interested in.
Oh, okay, okay.
So I mean, that's the reason I developed that particular model for him, because that's what he was looking for at this hospital. So yeah, but the statistical significance, you need to be careful with what it really means, and it's very unlikely. So people get really tied up on these p-values, and it's interpreted as, you know, if the p-value is less than 0.05, then it's a claim. But what we're really saying is the likelihood that another value more extreme than that current value exists. So a good idea to go read about significance or statistical significance versus practical significance. And practical significance is, just because we have statistical significance doesn't actually mean anything in the real world. So in the case with the model I was showing, the number of critical care patients with both or significant and had the highest coefficient. So that would be the first variable I'd want to target in the 6 hours till disaster level overcrowding. Let's see what else. The second thing when we start talking about our models is we want to look at goodness of fit tests. Now in RStudio, we have the AIC, which is really used to compare different models. There's a lot of other goodness of fit, but right now I'll just focus on this one because when you use the GLM function, it automatically gives you the AIC right here. And you want the lowest AIC value. So if you have 5 models and they each have different AIC values, your best model, or the model that fits the data the best, will be the one with the lowest AIC. And when we're talking about binary classifiers, there's something you need to know about confusion matrix. And basically, it is looking at the number of true positives, false positives, true negatives, and false negatives. And that's what this table demonstrates. And the two in this table, when we predicted no and it was actually no, then and then the diagonal predicted yes and actual yes. So that's when our model was correct. Alternatively, on the other side, if we predicted yes and it was actually no, then that would be a false positive. And if it predicted no and it was actually yes, then that would be our false negatives.
So would these be akin to type 1 and type 2 errors?
Kind of. I mean, yeah, right here. Type 1 error and type 2 error for false positive and false negatives. But it's what we're going to do with them to calculate our model like metrics. So we can use those values to calculate the accuracy of our model. So in that table before, it's the total positive plus the true positives plus the true negatives divided by the total, and that is the accuracy of our model. Now, something you have to be careful with is accuracy is dependent on your data and how you've split your data and your threshold. The value that I selected in here was 0.35. And depending on where I move my threshold value, I can change where the accuracy is calculated. So if you use, you have to set it up, but if you use the caret package, and there's a confusion matrix function that will give you your confusion matrix as well as all your model parameters. So in this case, the accuracy was 88%. The next thing we're interested in is sensitivity. So the number of correct positives divided by the total number of positives. So how likely are we to get a true positive? And specificity is kind of the opposite of that. When we are predicting a negative, when are we getting a negative? And that is also taken care of in the here. So because accuracy can be kind of manipulated, it's better to look at something called area under the curve, which is the AUC command. And what that looks at is something called the receiver operator curve. And then it finds the area under that curve, and that should be relatively the same depending on how you split your data, if you do a training and test set, or how your threshold value is. So it's a more respected version of accuracy than just running accuracy from a confusion matrix. let's see. So the second part is after you have your coefficients from that model, if you use those coefficients and you take a set of values. So let's say we've developed this model based on May of 2016, which is when the data came from, but we're going to use it today. We take all those variables for a particular hour, like right now, and plug them in, and then we would be able to predict whether disaster level overcrowding is within 6 hours. Because if we put it in and the model gives us the 1, then we'll know there's a disaster level overcrowding that's going to occur. Or if it's a 0, then we know that it's at least more than 6 hours away. So has this been helpful to you, Larry? Because based on what your question was?
Yeah. Just curious, how come you're not really talking about the adjusted R squared? Doesn't that show strength in how good the model is as well, or?
With logistic models, you don't want to use R squared. You want to use something called McFadden's R squared. I'll try to post something about that because it's a little bit different. But for logistic models, you can't just use straight R squared or adjusted R squared. You'll if you get further into it, you'll want to do something called the WALD test, WALD, as well as the McFadden's R squared, which I think it's like PR2 in function. I don't remember what package it's in R, but I can find it out. I'll write that down.
So it's best not to use R squared on the logistic one. What about a regular? Just
No,
general?
yeah, adjusted R squared is if you're just doing regular multiple regression, then adjusted R squared is the correct term. Simple linear regression, you can use R squared, but once you start adding the more than one dependent variable, then you want to use adjusted R squared. Now, and then with the logistic regression, you want to switch to specialized versions of those kinds of tests. I'll try to find a resource that I can send that'll tell you exactly how you'll want to do it for a logistic regression.
Oh, that'd be great. Thank you.
Yeah, and then in the data mining course next semester, we'll talk more about that because each of the models has special features to it, and sometimes, just like logistic regression, there's different things you want to do with different models. So,
and the AIC, is that work with just logistics, or is that?
No, you can use that with a lot of. It's just one metric of fit. I'll try to find a good. I know of another good website that has a bunch of different fit models, how they all compare, why some are better than others. AIC is one, BIC is another. I think it's like the ACACI is the AIC, and I think it's Bayesian IC for the second one, and then there's trying to think of all of them. But there's a huge list of different ways you can test fit. They're all calculated out different. Some people respect others more than, like if you're going to do research, there's certain ones you'd want to use. There's another one called like the normative fit index. But yeah, there's a good website that explains the difference between each of them. So I'll try to post that one too.
Now, when you use the different ones, are they going to all kind of be general, the same grouping, or am I going to have? Would you have some that say this is a good fit and some that say this is a terrible fit, or they all kind of collaborate with each other?
Well, the AIC one is to compare different models. There's other ones that tell you the fit of your model to itself. Let's see, I think there's a way to get it in R using an extension to the summary function, and you can get a list of, it's like summary.fit, I think, and you'll get a whole list of different fit indices for your model.
Okay, I think I understand now. Okay.
So, excuse me,
Yeah.
what did you mean by logistics model?
A logistic regression model.
Yes, the one you were just discussing.
It's logistic regression because we use that logistic curve from, go back. That's how it's got its name. But it's just a binary classifier usually, but you can also use it to predict, well, you're predicting between two classes. In this case, it's 1 or 0.
Okay, so it's really a logical function as opposed to, say, a log function. Okay, I understand.
Yeah, not a log, because that would, no, because this is, the logistic function is based on this, I think it's called a sigmoid curve. The log function,
Right.
it starts at 0 and goes up. So it's a little different, but I think it has to do with like log odds. But oops. Last part, for the project expectations, everybody's doing a pretty good job on the project, I think. But the last part is to do a recording, and you can do that in PowerPoint, or if you want to like video record yourself giving it, either way, just so and just kind of explain what you did, what your recommendations are based on your analysis. I would assume it would take like, I don't know, 15 minutes, but however long it takes is fine. Do you guys have any questions particular to this? There's a website for how you record in PowerPoint if that's the route you're deciding to go.
So basically, you just want us to tie everything together from the three
Yeah.
prior assignments?
Yeah. So yeah, like I said, like from the perspective of a consultant, like, because that's kind of more like what you guys, unless you have a healthcare background, you came in, the CIO has this particular problem, so you do your background research so you understand the problem, then you do some initial analysis, and then you develop a model, and then based on that model, you're going to make a recommendation to make a decision. And that was kind of the idea of the project, and now it culminates in the presentation.
Yeah, I don't think I have a model.
You don't have a model?
And well, I guess model means different things to different people.
In this case, I mean like a mathematical model, like the logistic regression model.
Okay.
I assume that's what most people would do at this level, would just be some kind of simple regression type model. Because we haven't focused on the more advanced models, because that's what we're going to do in the next class.
Do you want us to test our models, run like an analysis on it of 30% and then 70% to, I guess, some of the stuff you were showing in this lesson? Is that what you want us to do to show the strength of our model?
No, I'm not expecting you guys to do a train and test set because we didn't really focus on it in this.
Okay.
At this level, I want to see that you guys can run a regression model and then try to interpret it based on your background research. And so, like, if you were actually an analyst, how would you explain this to somebody? And have it back up by defending what your analysis was.